In this guide, I will explain everything there is to know about custom shapes, all the way from creating your very first shapes file to advanced shape creation and gimmicks. With that said, let's begin by creating a new shape file. There are 3 ways to do this, and the first one is the same way that we made our blocks.lua file in the previous video. First thing you're going to do is just right-click anywhere in this folder, go to New, and then I'm going to go off screen a bit, but you hit New Text Document, and then change this to Shapes.lua. You're going to hit enter, and when it asks you if you want to change the file name extension, hit yes, and now you've made your Shapes.lua file. The second way is what most people do when they've already have shapes lying around somewhere. Because most mods have very similar shapes, I'm just going to copy and paste another file from a different mod into this one. First thing I'm going to do is just navigate to somewhere that has the shapes file that I want. So in this case, I'm going into a different mod. I'm hitting Control-C, and then going back to my mod and hitting Control-V, and I have a shapes file in here that already has some shapes in it. In fact, there's a standardized open source shapes file download link in the description that you are free to use to do exactly this. Finally, the last way to make a shapes file is to do it through Notepad++. So I'm going to open Notepad++ in just a second and show you how to do that. The third way to make a shapes file through Notepad++ is to go up here where it says File, hit File and New. Now, this is still a text document, and as you can see, there aren't like funny colors when I add stuff. It does select brackets, but like numbers aren't colored the way they would be in a Lua file. So what you need to do here is hit File and then Save As. And when this screen pops up, it should have already auto-populated to your mods folder. If it hasn't, again, that's C, Users, Your Name, Saved Games, Reassembly, Mods, Your Mod Name, and then we just want this to go into our actual mod name, not where we start our block, and rename this as Shapes. And in this drop-down folder, or in this drop-down, you can go and scroll and select Lua. Usually I try to stay away from this because, as you can tell, it takes a lot longer than the other ways, but this is an option if for some reason you want to do this. So you just hit save, and now you can see that it's been updated to a Shapes.lua, and our text is changing color, and we can see this red line over here that indicates where our bracket is going from. Now we can get into actual shape coding. I've already copy-pasted some code into here so that it's easier to look at. First thing to notice is obviously the closing and opening bracket of the file. This is going to be in everything. It's going to be in blocks, shapes, regions, and factions, and technically audio, but that's a video for another time. Make sure you have this in all of your files, basically. Then we get to the actual shape code. This is your shape. So if you wanted to make another shape, you could copy-paste this, and here's one shape, here's another shape. The amount of brackets here is very specific. So pay attention, it's one bracket, ID, and then another bracket, and then here are your scales of the shape. So if I wanted to add another scale, I would copy both of these brackets and add another scale this way. So this is scale 2 and scale 1. And then we have our closing bracket for the second bracket, and we have our closing bracket for the first bracket. Back to IDs. IDs are usually between 200,000 and 290,000. Usually what I just do is I copy my group ID and then add 4 zeros to it. So if this was group 90, I would make this 900,000. But because we are 20, and I'm just going to go with 20,000, and that way it's easier to tell which shapefile is associated with which mod when you have multiple mods open in Notepad. Now, let's talk about verts. I want to make a 1x3 triangle, so that's 10 reassembly units by 30 reassembly units. First thing I'm going to do is put a point at 0, 0. That's not where every first point has to be. You could put your first point anywhere, and the center of the shape literally doesn't matter. So I could have my shape point be at 300, 300, and go up 10 to the right by 30, and then back, and that would totally work just fine, but this makes it easier to do math in your head. The next port we want is we want it to go up. Shapes have to be written clockwise. If you write it counterclockwise, it's not going to work. Now, There are some applications for counterclockwise shapes that I'm going to cover later on in the video, but that gets pretty complicated, and 99% of the time you aren't interested in counterclockwise shapes. So we're going to go clockwise, which is up 10, and we're going to make a point at 0, 10, and then to finish off a triangle, we're going to make a point at 30, 0. So this is side length 0, because it starts at 0. This is side length 1, and then side length 2 is from -30 back to the start. To add ports, what we're going to do is just indent this, and we're going to add ports on our first side now. Because a regular 10 by 10 square has a port in the middle of it, that's 5 reassembly units. And because this is just 10 long, we want it to be in the middle of that. So that's 5 reassembly units from the edge. That way, if you put these together, you're going to be able to connect them very easily. To do that, we put 0, and this is the side length. So side length 0, again, was the side length from these from this point to this point. And then we're going to put 1/2, because it is 1/2 of the way from 0, 0 to 0, 10. And then we're going to close our bracket, and that's our first port for this side length done. Then I'm going to temporarily skip this, because this side length is you have to use a bit of trig to get this to work out well. So I'm going to skip straight to edge 2, which is going to go from 30, 0 to 0, 0. We know the length of that one is 30 reassembly units, and we want there to be 3 ports on it because it fits 3 scale 1 squares. So that's going to be 5 reassembly units from the edge, and then a spacings of 10. So 5 over 30, or whoops, I forgot to specify the side length. So side length of 2, and then 5 over 30, and then we're going to close our bracket and actually add another one here. So 2, 15 over 30, and then open another bracket, 2, 25 over 30, and close that bracket. And this will give us the 3 ports we want to be able to fit 3 scale 1 squares onto this side length between here and here. You can add a bit of spacing here so that it looks nicer. Now, we know that these simplify down, so I'm going to just do that really quickly. As you get more into making shapes, this becomes a lot easier, because what you end up doing is you multiply the side length by 2 and divide by 10, and then you go up in increments of 2. So 1/6, 3/6, and then 5/6 for a 30 long shape. If it was like a 100 long shape, you would have 1/10, 3/10, 5/10, and so on. Finally, let's go back and do our 1 port that we haven't done yet. So we can actually just copy paste this and then edit the ports from here. The first thing we can do is notice that because this is a triangle and we know 2 side lengths, we can actually figure out the third length, which is this crazy number. And I'm actually going to simplify this down a bit so that it's easier to look at. Now, obviously, we're going to want our first, or I guess our second port to be in the center of that, so that when you put when you put 3 blocks there, it's centered on the length of that triangle. So to do that, we're going to divide that number by 2 and get this number. Again, simplify that down a bit. And this is going to give us a port halfway across that length. You could put just 1/2, but this is going to come in handy for what we're about to do next, because now you can copy and paste this, and we know that if we want to fit a scale 10 square or a scale 1 square in between ports, we want the ports to be a distance of 10 apart. So we can subtract 10 from this to get 5, and we can add 10 to this to get 25, and this is going to be our 3 ports. And now when we load this in the game, you will actually see that it fits a square perfectly. Obviously, the side isn't 30 long, so you're not going to be able to tessellate squares infinitely, but we will be able to fit 3 squares onto this side length. The only thing left for us to do is remember to change the port to 1. Finally, what we can do is we can actually just copy and paste this entire scale here and multiply the verts by 2 to make it twice as big. This will work for any shape you ever make, so if you ever need to make a shape twice as big, you can just multiply it by 2. Now, you will have to change the ports because now this side length is 20 long, and if we want to fit 2 squares in there, you remember the trick from earlier, you multiply 20 by 2 and divide by 10 to get 4. So we're going to make 1/4 and then 3/4. Same thing here, this side length is now 60 long, multiply 60 by 2, you get 120, and divide by 10 and you get 12. So we can actually just copy paste, or we can update this with 12. Copy paste this, and then change these values to keep going up. So 5, 7, 9, and 11. Now this side length is interesting because it has doubled in length, but we're actually going to be able to set up 7 ports on there. And normally I wouldn't know that, I just do because of movie magic or editing magic, I guess. But first things first, we're just gonna double the value because again, this side length has doubled from this. So this is doubled, this is still our center point. Now what we can do is we can copy paste this a few times. 1, 2, 3, 4, 5, 6, 7. And here's our middle one. This is halfway there. Now what we can do is we can actually subtract 10. And you can see that we're at 11. So we can even subtract 1 more and have a port like this. Or what we can do is go in the other direction, and we're also going to go in the other direction. And we still have a bit of space because this goes to 63. So we can go up to 61 out of 63. Now, when you do this, it's going to be a bit awkward because if you try to put squares on this, they're going to overlap. You can tell that there's only like about 1.5 units between in here and here. So I will leave that in just to show you what that looks like, but we are also going to make a shape that has the correct amount of ports on it, which would be 6. And to do that, it's very simple. We're going to take our halfway point and add 5 to it. So here's our halfway point. We're going to add 5 to this, so that's 36. And then we're going to have 46 and 56. And then over here, we're going to subtract 5 from this. Oops. So this is about this much. And then we can just subtract 10 from that. So it's going to be 16 and 6. And now you can very obviously tell that all of these are spaced 10 units apart, and it's not centered at halfway anymore. It's centered at the distance between these two. So I'm actually going to make a third scale of this and kind of show you what these two look like versus each other. Once we've saved this, it's actually super easy to put this into our hull. All we have to do is copy this ID, and I'm going to go into this block and just change shape equals square into shape of the shape ID. So now this is going to be this shape. And what we can do is we can just copy paste our extends from over here back into here. Change the values a tiny bit so that this is 300 and it extends off of this one. And now this shape is going to have a scale 2 and this shape is going to have a scale 3. And we can save this, open it in Reassembly, and I'll show you what that looks like. Here we are in Reassembly. It's usually good practice once you open the game to double check in here. And actually we do have 4 errors, but this is just some overwriting because I have quote unquote conflicts or something. If you see overwriting shape, 99% of the time this doesn't actually mean anything and you can just ignore it. So we're going to hit OK on that, go back and go into our sandbox where we can write CL to clear everything and then min P20 to get our palette. And you can see that this is our 3x1 scale square. So if we grab this red square, you can see that it fits perfectly. Now, obviously, if I put it here this is kind of what I was talking about. This isn't 30 long, and it's impossible to have it be 30 long and have this one also be 30 long. So you're going to have a bit of a gap here, but at least you can have the squares kind of touch each other like that. And quickly, let's look at the other two scales we made. So they look very similar because the only thing that's changed is the ports. But as you can tell, the side length is fitting everything perfectly. Squares fit here. And now I will kind of show you the difference. This one has 7 ports, and you can see that the squares are coming off of the edge here, versus this one, they are fitting in here. So if I was to try and put another square here, I'm going to have a lot of overlap, versus if I was going to have a square here, there's still that kind of ugly space, which we can't really do much about, but at least it's not overlapping anymore. We still have this square regardless of what we do. It's just in a different spot. Honestly, pick your poison. The benefit for this one is that you can potentially move this, you can potentially move this block around from here to here, but that doesn't really make that much of an impact, and personally I think that this looks better, so I would go with this one. Now, one thing to notice is that whenever you're working with shapes and you change stuff in the shapes guide, if you are changing verts, you need to clear and then reload and then type in your min p again, because if you try and reload a shape like this and you've changed the verts on it, it will crash the game. If you're just changing ports, usually it's fine, but honestly, I'd say just play it safe, clear everything before you reload it, and that way you never have to worry about your game crashing. Now, if you were paying attention, you might have noticed that we made a 1x3 scale triangle, but there isn't a mirror for it, which would be really annoying if you're trying to build a ship and you only have one side of this triangle and it doesn't mirror. So you might be thinking, oh boy, I have to redo all of this again, but in the opposite direction. And no, the game actually is a lot simpler than that, and it's a lot nicer. What we can do instead is we can actually just put an open bracket, put in the new shape ID, put a comma, put an open and a closed bracket, comma, mirror underscore of, and then equals, and then the original shape ID, and then close your bracket. And this piece of code is going to replicate this entirely, except it's going to make a mirror of it. Now, what you will have to do is save this and go into Hull and remake another shape, which has a shape, make another block which has a shape with the new mirror ID, and that way you can kind of make this a scale, or this is the right side and this is like the left side or whatever, but you do have to redefine the new shape in your blocks.lua. Let's open Reassembly and see what that looks like. So again, we're in Sandbox, we're going to hit REL, and then we're going to hit MINP and 20, MINP 20, and you can see that now our shape has a mirror, and it was as simple as just adding that one line of code to our Shapes.lua file, and then making new stuff for our blocks. And you can see here that it's also mirroring correctly in terms of where stuff is connected. The last thing I want to talk about before we go on to the next portion of our video and start talking about functional shapes is includes. So you can actually do this exact same thing for not only shapes, but every single type of thing in the game. Blocks, regions, factions, and shapes. Usually, I don't think I've ever seen a mod that uses include for blocks, but you can just put it in the same folder, or if you want, you can even make a new folder called shape and then call this like Shapes.2 or something, and that would include the shapes from there. I'm not going to test this out just because I know it works, and do note again, you do not have the opening and closing bracket inside of the includes file. You would just have this copied in there. If you want to use include for shapes or whatever, go ahead and do that. That's just something as an option. The last thing I want to talk about before we get into advanced shapemaking is functional shapemaking. So that's going to be everything from thrusters to weapon in and out ports, routes, etc. Let's start with thrusters because that's by far going to be the most common functional shape that you're going to use. If you take a look at the first shape scale with a comment on it that says good thruster, or this shape over here, you will see that we have our regular port on edge 2, but we also have a port on edge 0 with thruster out on it. So normally you would just have 0, 1/2 and then a closed bracket, but in this case we're also putting comma thruster underscore out in all caps. Make sure you capitalize everything. This is going to be the thruster out port. Thruster out ports always thrust in the left direction when you first spawn it in. So if you spawn in, if you look at the second scale, which is named bad thruster, you will see that the port is on the right side, but the thrust will still go to the left. Obviously, if I rotate it 100 degrees, now this is going to go to the right, but when it first spawns in, thrust goes to the left. So just to show you how that looks, when we slap this on a core and press the thrust button, you can see that we are going in the direction that we want to be going, which is that way. Obviously, I'm not actually moving because the thruster value is super, super low, but the thruster works as intended. And just to show you what this would look like, normally you would expect this to go in the opposite direction, but actually it's going to go to the left because that is what the default state for the thruster was. Another thing with thruster out ports is that you only ever use one thruster out port. Now, there is one exception to this, and we're going to get to that in just a second. But other than that, if you put more than one thruster out port, the game is just going to decide and it picks the leftmost one. So the rightmost one or anything else here isn't going to be used. But if you're making just a regular thruster, you only ever need one thruster out port, no matter how big it is. Now we can go into stackable thrusters. So this is more or less the same as this one, except now we've replaced this port, this regular port, we've added a thruster in tag to it. A thruster in tag can connect to normal ports, but it can also connect to thruster ports. So if you load in a Terran palette, you can see that this is how normal Terran thrusters work, except in this case they happen to be squares. Actually, we can load one in right now and show you that the port colors are the same. We have this blue one on this side and this yellow one on this side. So the blue is a thruster in and the yellow one is a thruster out. And that way you can attach this to anything. You can even do something like this. I'm not going to thrust with this because it's actually going to move, but it would go in that direction. One interesting thing that you can do with stackable thrusters is if you put another thruster out port on the front of it. So kind of what I was getting at here, this is the only acceptable case where you would have two or more than one thruster out port. And that prevents this, because it's a thruster out port, it can't connect to a regular port. So you need a thruster out port, and then the thruster in port can connect to this. And that will let you make stuff like in antecedents, you have these thrusters, which have a base, and then this can only connect to here. It can't connect to regular hull, it can only connect to here. And that's how you make thrusters like this, where it's stackable, but you need a base for it. Now let's get rid of this really quickly and go back to looking at thrusters. You might have noticed that instead of making another port, we actually separate these with a downwards line. I don't remember what it's called, but it is just the kind of slash there that we're putting. I'm going to edit this later and add in the actual name of it, but we're putting a character like that instead of a comma or instead of another port, and that way we can put two different functions on one port. And the last example of this is this non-attachable thruster. So it looks almost the same. Actually, it looks the same as just this regular thruster we had before, except the difference is because this one also has a none port on it, which we're going to get more into a bit later. You can attach stackable thrusters to the one that doesn't have a none port on it, but you can't attach anything to this one that has a none port on it. You can't attach regular blocks, you can't attach thruster out, you can't attach thruster in. nothing will fit into here because it has a none port, but it will still thrust. So if you ever have a faction where, like antecedents, if you have a thruster like this, and you want this thruster to connect to here, but when you also have like a movement thruster and you don't want this to be able to attach to this thruster, then on this port over here, you would just add a none port, and that way this will never be able to attach to this. It's just going to be, it's not stackable. The next port I'm going to be talking about is a weapon in and out port. There's only two of these, the weapon in and weapon out, and for these ones you can put them anywhere on the block, and you can put them anywhere you want, basically. Do note that weapon in ports do not attach to regular ports, and weapon out ports do not attach to regular ports. Kind of hard to see here because it looks like the line is going through, but that's just the weapon in connecting to the weapon out. If you do want them to connect, you are going to need to add just a separate port, like what I'm doing right here, and that way you're going to have a port with weapon in and a port that's just a regular port, and you're going to be able to attach that to anything. But here, for now, the weapon in port attaches to the weapon out port, and the normal port attaches to the normal port. Best use case for this is Faction 4 or the Tinkerel's kind of rail cannons, where this will have a weapon out, so bullets are fired from this, and then weapon in connects to the weapon out, and you can just keep stacking stuff like this. I don't know why you would ever want a weapon in and weapon out port on the same edge, but if you ever figure out a reason to do that, you absolutely can, in the same way that I'm showing you right here. You just put the strike through line there, and then you put weapon in and weapon out. The next block type I want to talk about is root. Now, it's a bit hard to tell apart from the other ones because we only have blue ports, regular ports, and yellow ports. But a root port is literally just the only port that can attach to environmental blocks. So if I was to spawn in an asteroid, which I'm only spawning in an asteroid of one size, in Sandbox I can obviously connect anything I want to this, but if you want buildings, you are going to need to have a root port, and that way when it naturally spawns in game, the root port will be able to attach to asteroids. If you don't have a root port on your blocks, it's not going to attach to an asteroid. If I just put a root port on an actual ship, there's a chance that it might spawn just like attached to the asteroid. So that's what root ports are for. And finally, let's talk about none ports a bit more. None ports are useful because A, they prevent you from attaching anything to the port that was defined. So in this example, I have these two ports, or in this one, I have this one port, but then I'm also putting none ports on these two kind of middle edges over here, and you cannot attach anything to these middle ports. There is a port there, but because it's a none port, you can't attach anything there. But the other interesting thing that none ports do, if you look at this block, the no SP ports block, you will notice that the only ports on it are this one and this one. And if we go outside of editor mode into view mode, you'll see that the ports that nothing is attached to disappear. So this is useful if you want to be making like a Chad line indicator or something like an antecedents. I have these Chad lines where you can see that this block is a Chad line and this one isn't, but once you go out of editor mode, that port disappears because there's nothing in there. However, if you do want to make a stacked shape, or if you do want to like make some shape folding thing where you have some lines going on the inside of your shape to provide extra detail, this is an alternative to shrouding. Back when shrouding didn't exist, people did this. You use a none port here, and these lines will stay attached and you won't be able to connect anything to them. I also do want to touch a tiny bit on just missile launchers, missiles and launchers, I guess. They are a bit out of scope for this video just because of how complicated they can get, but if I ever do end up making a guide just for launchers and drones, there will be more advanced shape creation in there. In terms of the missile itself, so this part that generates when you attach the launcher block to a core, this part is very, very similar to a thruster in that you have a missile port. You can also add a separate thruster port if you want to, but the thruster port is by default going to be edge 0, so the backwards facing edge. might not necessarily be an edge 0. In this case, it is. So the backward facing edge is going to be the thruster edge. Now, if I were to define this edge, edge 1, as the missile port, what's going to happen is it's going to attach the block like this. It's going to find missile port and launcher port, and it's going to attach them together. But then edge 0, which is the one with the thruster on it, is now going to be pointing upwards. So what you get is missiles that shoot upwards. If you do put edge 0 and the missile on the same edge, then it'll shoot forwards like a regular missile. Just do know that is something you can do if you're ever interested in that. In terms of the launcher itself, you have the regular port and the launcher port. Regular ports, of course, can only connect to the regular ports again. Launcher ports can also connect to the regular ports, and unfortunately you can't stop that by putting a none port on there, because if you put a none port on there, then the missile itself won't generate. But you can have as many of these as you want, and you can face them in basically every direction, as if you spawn in like a mini palette of the Borg, they have some missile launchers like this one, which have missiles that, or I guess drones, that generate in every direction. And then, as you can clearly see here, it's also totally fine if they overlap. But drones will be gone over in a later video in much more detail than this. This last part of the guide is going to cover advanced shape making. Most of this stuff is just going to be how to break rules, so stuff like concave shapes, or like making shapes that are clockwise or counterclockwise instead of clockwise. And then I'm also going to talk a bit about the rendering engine in the game and a bit about some programs that you can use to help yourself make shapes. Just to show some examples of what custom shapes can achieve. First of all, we're just going to talk about the shrouds on this thing. Obviously, this trail here and some of these triangles are not things that you could do with just the vanilla shapes. You need a high aptitude of custom shapes to be able to come up with this, and then also understand the rendering engine to get these kind of like icicle shards to appear the way that they do here. Another thing is, these shrouds don't look particularly complicated, but the cool thing about these ones is that this is this is a clockwise shape and this is a counterclockwise shape. So you can put one inside of the other, and that way you can have a weapon that shoots a bullet which can have two different types of frags in it. Without further ado, let's jump right into it. Let's start by talking about counterclockwise shapes. Up here we have a square that's just a clockwise shape, and as you can see, it easily tiles with itself. Now, counterclockwise shapes are super simple, and the only reason I'm putting this in an advanced guide is because to help with confusion of new players. But literally, if you just define a block in the counterclockwise direction, what you can end up doing is attaching stuff to the inside of blocks like this. So right here, you can see that these ports are actually attached to each other, or like I can attach a port like this, and then these things will also stack the same way that a clockwise shape will stack. It's just that if you put them together, weird stuff starts to happen. It's been suggested a couple of times as a haha funny joke that someone make a mod with only counterclockwise shapes, and if you want to, that is totally reasonable. The only thing is you basically are limiting yourself to not use any vanilla shapes in the mod. It kind of doesn't matter as long as you're consistent. Now, I showed in the intro this faction, which actually makes use of both counterclockwise shapes and clockwise shapes on purpose. And the way this works is that there is a very small vert over here, or I guess side length over here, with a weapon out, and a very small side length over here with a weapon in, and this shape is defined counterclockwise. So this can only attach to these guns, and it's counterclockwise, so it fits into the same thing, and then you end up having a gun that can shoot 2 bullets at once. So normally, normally you can't even attach this to the gun, but normally when you fire this, it just kind of looks like that, versus if you also attach this to it, now you have 2 things. You have the cross thing and the kind of like little frag explosion there. Next thing is how the game renders its shapes. Depending on where you put the first vert on your shape, that is the starting point for the shape. So let's just say we put our first vert here. We'll call this A. I'll fix that actually a bit more so it looks like more like an A. What the shape is going to do now, if we go clockwise, it's going to draw a line between this point, and then it's going to draw a line between this point, and fill in this area, and it's going to draw on a line between this point, and then fill in this area, and it's going to finish its shape creation. So when you're making a convex shape, so like a square or something, this isn't a problem, because what happens is you have your point here, and it draws a point between here and here, and here and here, and it makes this triangle, shades it in, and then here and here, and it shades this triangle in. What doesn't work so well is when you have stuff like this, and you end up getting out of bounds shading, because this is not where you want stuff to be shaded. This is bad. So a quick solution to that would be if you were to put your first vert here. Now what happens is if we're going counterclockwise, it puts the first vert here, and the second vert here fills in this area, and then puts the third vert here and fills in this area. Hopefully that makes sense, but if not, I will show this in the actual game by creating this shape and then rendering it with a point A at here and then here. I'm also going to show you how I made that first shroud at the very beginning, because that one has translucent colors, so you can actually see it overlapping itself to create that extra spicy kind of icicle effect there. As I said before, this concave shape is the first one where the first vert is A over here, and this one is the second one where point A, our starting point, is over here. So you can clearly see that it's rendered this line between here, and it's kind of filled this in very, very uglily. It shouldn't have done that with this kind of triangle between the three verts there. So it went to this first vert, and then it went to the second vert, and it drew a triangle between those three, and it went to these two verts, and it drew a triangle between these three. I'm not 100% sure how it works, but you understand the point that if it's at an edge where this vert can see everything without any interference, you get a nice shape without kind of overlapping like this. Now, in this specific scenario, our point A was over here. So what I did to make this shape was I went clockwise this way, and I went down to the spike, but instead of going up, because I knew I was going to be working with semi-transparent colors, you can see the color under it, I went back a bit to make an intentional concavity. And normally this looks really, really bad, but because this is an ice faction and we like to have these kind of like irregularities to make it more realistic, what ends up happening is you get this really nice kind of triangle with two different shades that contrasts with the rest of it. So it's not just a flat color. And then same thing over here. We have a line going from here all the way down to here because this goes inwards a bit before coming back outwards. One thing to note with custom shapes is that the way it renders the shape is also kind of how it renders the actual shape itself, I guess. So this line here that you can see is kind of the hitbox for the shape. When you're thinking of hitboxes for shapes, you would think of the way if you drag the string around each vert and then pulled it tight, you would have a tight string between these two verts, and this is the actual shape hitbox. So the shape might look like this, but the hitbox is like this, which is why when working with Chalps and making these thrusters, you can see that my shape is actually just a square and I shrouded over it, because this hitbox, if it went out like this, would actually go from this point all the way to this edge point, and you would have trouble connecting things to these four verts because it's on the inside of the hitbox. It'd be like stacking shapes. So when you're making concave shapes intentionally for building with, be very wary that those hitboxes are going to cause problems. Finally, let's talk about what is currently the most powerful existing tool for reassembly modders. This is GeoGebra. You might have heard people using it or talking about it in the reassembly server if you're a part of that. But the way this works is that you put in a point, so like a equals 0, 0, and it shows up over here. And then at the very end, you can list your points, so a, and it actually gives you the vert data. It doesn't give you the port data because it's not going to calculate like how many ports you want on a shape. That's way too complicated. But it does give you the vert data automatically. And the interesting thing with this is that if you're making shrouds, especially like stuff for shrouds, you can choose a file. And like, I'm going to choose this picture of an arrow that I had prepared and hit OK. And then you can like kind of move it around because you know that a reassembly unit is 10. Let's say we want this to be like 20 long so that we have a 20 long arrow. And we can kind of center it here and start drawing. So if we have a point a equals 0, 0, we can go up to a equals like 5, 0. Whoops. B equals 0, 0. And then you can also drag these points around. So like figure out your arrowhead like this. C equals, this looks like 3, 0.8 or something. Wait, maybe a lot lower than that, I guess. D, 20.8 again. And then we can put this down here and basically mirror these shapes. Or we can actually just mirror reflect about line, select the points that we want, and reflect over the x-axis. And we now have our final shape A prime, B, C, D, D prime, C prime, B prime, A prime. And you know this is going to work because you can draw straight lines to everything. So unfortunately, we're not going to be able to get the feathers in because that would mean drawing a straight line from A to over here, which would create some big clipping issues. But this is an easy way to help visualize your shapes. And now you can copy down these verts and get it into shape mode. I'm not going to take you through the whole process of learning this program because it is fairly easy, but really the only things I ever use are you go to Tools, hit Media and Image. You can drag these points around once you make them. And then there's also the Reflect About line where you select, whoops, you have to hit Reflect About line first, select the points that you're interested in. So like you select BC or something. I don't know why it's not letting me do this now. It might be because I've already reflected it. And then, oh yeah, because these points are already reflected. So if I made another point and then you select the axis that you want it to be reflected over. So in this case, I can just hit the x-axis and it'll reflect over that. Other than that, a lot of these are usually pretty useless. I guess there's also, if you click more, there's even more stuff. You can like make a polygon. You can make midpoints. You can do a lot with this program. And as you start to get into more mathy shapes, especially ones that aren't specifically for shrouds, some of this might be a lot more important to you. Like you can rotate stuff. The one last thing I want to say about making custom shapes is that shrouds have this really, really weird thing where for some reason they don't relocate. So to counteract that, usually what I'll do is I'll just go online to a random number generator. And then if my faction ID has like, or if my regular shape ID is like 200,000 something, I will add that random 4-digit long number to the front of that. So that way it's completely out of relocation range. And when it's on the Steam Workshop, it's safe from someone else using the same shape. Now, if someone else does happen to accidentally use the same shape as you for a different shape or shape ID for the different shape, you might run into problems, but because it's a random 4-digit number, you can just Control F it and change it to something. And a cool part about having IDs that don't relocate for specifically shrouds, you can actually keep those consistent between mods. So if you have like a circle between mods or a circle shroud that you use in multiple mods, what you can end up doing is have the same shape ID for that circle in all of your mods. And that way you don't really have to worry about it ever being wrong. Thanks for watching, and I hope that helped you learn more about shapes.